All right, let's jump right in. We've got this question that's becoming more and more important. How does a normal, everyday website prove who it is in the new world of the blockchain? We're actually going to follow the journey of one specific domain name as it tries to get a secure, verifiable identity. It's a story all about bridging two very, very different internets. So think about it. In this decentralized world, there's no single boss, no central company saying, yep, that's the real one. So how can a website, say Preferido.us, prove that it's actually Preferido.us on the blockchain? How do you build that bridge of trust between the old web and the new one? That's the core puzzle we're digging into today. Okay, so to really get this, we've got to understand the two different worlds we're trying to connect. You've got Web 2, right? That's the internet most of us know, built on the good old centralized domain name system, or DNS. But then you have Web 3. This is where decentralized identities, like Neutra.eth, live on something called the Ethereum Name Service, or ENS. And trust me, these two worlds play by completely different rulebooks. So here's the million-dollar question. How do you make these two totally different systems trust each other? The real challenge is building this verifiable bridge, you know? But here's the catch. You have to do it without some big company standing in the middle giving the thumbs up. No middlemen allowed. Well, it turns out the solution is actually hiding in plain sight. It's a piece of internet security tech that's been around for a while, but it's suddenly found this incredibly powerful new job to do. And it's called DNSSEC. Now, the easiest way to think about it is like a digital passport for your website. It uses these fancy digital signatures to prove that any information coming from that domain is the real deal, and that nobody's messed with it along the way. This is exactly the kind of proof of identity we've been looking for. This whole trust thing, it's not just one signature. It's built like a chain, link by link. It starts way at the top of the internet, something called the root zone. That root signs off on the next level down, in our case, the .us zone. Then the .us zone signs off on our domain, preferido.us. See how that works? Each link vouches for the one below it, creating this unbreakable, verifiable chain of trust all the way down. But here's where our story begins. On June 18th, that chain of trust, it was broken. Or, well, it hadn't even been built yet. The logs were crystal clear. No DS records found. That digital passport we were talking about, it just didn't exist. The domain had zero verifiable identity. Okay, so the first step seems obvious, right? Just activate DNSSEC. But you know how it is with powerful tech? Flipping the switch is rarely the end of the story. In this case, it was the beginning of a whole new mystery. So fast forward to June 23rd. DNSSEC is officially turned on. That chain of trust should have been complete, but it wasn't. Anyone trying to verify the domain's identity was just getting errors. Something was off. It was subtle, yeah, but it was also critically wrong. And when they ran the diagnostics, they got this very specific, kind of cryptic error. But this was the smoking gun. RSIGS missing for a key with the ID 2751. So what does that actually mean? In plain English, a super important piece of that digital passport signature was just missing in action. Digging in, they figured out what was going on. The domain had two security keys. Key number 41969, that one was doing its job perfectly, signing all the records. But key 2751, yup, the one from our error message, it was registered. It was announced to the world, but it wasn't actually signing anything. I love this analogy. It's like having two pilots listed for a flight, but only one of them actually bothered to show up in the cockpit. So what gives? Why was one key doing all the work while the other one was just sitting there? It was time to really crack the code on this digital whodunit. And look, this wasn't some instant fix. Let's recap the timeline. On June 18th, nothing. DNSSEC was inactive. By the 23rd, it's on, but it's totally broken. It actually took another 6 full days of troubleshooting to finally nail down the problem on June 29th. So what was the final diagnosis? When you really boil it all down, it's surprisingly simple. The system basically shouted to the entire internet, Hey everyone, I've got this brand new security key, number 2751. You can use it to verify me. But then, it never actually used that key to sign anything. It was a promise made, but a promise not kept. All right, so on June 29th, the fix finally went live. A few things happened. The name servers got updated, they applied a proper key rotation, and the whole system was basically refreshed to make sure that any key it announced was actually, doing its job and signing things. And the result? Boom. Success. The afterlogs show a perfectly validated chain. That troublesome key, 2751, the one that was causing all the headaches, it's now correctly verified. The digital passport is officially stamped, valid, and trusted by everyone. Okay, so with that bridge of trust finally secure and totally stable, it was time for the main event. This is what it was all about, connecting our regular Web 2 domain to its Web 3 identity. Time for the final handshake. So first things first, they ran a quick check. Was there already some kind of link to the Ethereum name service? The answer came back loud and clear, NX domain. That just means non-existent domain. So nope, no connection, a big ol' red X. Now, check this out. This is where the magic happens. The entire final connection is made just by adding one single simple line of text into the domain's DNS settings. This little TXT record is basically an instruction. It just says, hey, the ENS identity for this domain is nutcher.eth. And because this little record is now protected by our fully working DNSSEC, the whole Web3 world can trust it, no questions asked.
And the payoff was instant. I mean, immediately. They ran the exact same command again, and this time a totally different result. No error. The record was found, the link was live, the Web 2 domain and the Web 3 identity were now officially, and more importantly, verifiably connected. We got our big green check mark.
But maybe the most incredible number in this entire story is this one, 0. That's exactly how many on-chain blockchain transactions it took to make this happen. Think about that. No miners, no paying for gas fees, no waiting around for block confirmations. The whole thing was done using the internet infrastructure that's already there. So what's the big takeaway here? What does this all mean? Well, a standard, everyday domain name, preferdo.us, now has a provable cryptographic link to a blockchain identity, nutcher.eth, and that connection is absolutely rock solid, all thanks to that DNSSEC chain of trust. And the crucial part, it was all done without spending a single cent on blockchain fees. This shows a seriously powerful new way to bridge these two internets. So let's step back. We just watched a simple domain name get its own digital passport and earn a trusted identity in a completely new digital world. So it really makes you wonder, if we can do all this for a website, what else can we give a secure, verifiable identity to? What does this mean for the future of how we all prove who or what we are online? Something to think about. Thanks for joining me for this explainer.